Assalamu alaikum. Today we are going to cover the topic inequalities and equations. A levels, this is A2, P3 and code is 9709. Let's first discuss the definition of inequalities. Inequalities define a range of possible values for a variable rather than a single specific value. In mathematics, an inequality is a statement that two mathematical expressions are not equal. It uses symbols like less than, greater than, less than equal to, and greater than and equal to. And is equal to not means not equal to compare the values of the expression. Equations. In mathematics, an equation is a statement that two mathematical expressions are equal. It is formed by placing an equal sign between two expressions. In prior knowledge, students should be able to factorize quadratic equations, solving exponential functions by taking logs. In the course of solving equations and inequalities, students should be able to understand the meanings of x modulus and use relations such as a modulus equals b modulus. This is the same as a square equals b square because you remove the modulus sign by squaring both sides. And x minus a modulus is less than b. This is the same as you are going to write x is less than a plus b greater than a minus b. This comes by taking the plus minus sign with the x minus a modulus. Let's start with the meanings of x modulus or absolute value of x. So absolute value of x equals x when x is greater than and equal to 0. Absolute value of x equals negative x when x is less than equal to 0. For example, if I write negative 3 modulus equals, this is minus times minus 3, which is positive 3. And modulus of 2 is positive 2. Take negative 300 modulus, so this is negative times negative 300, which is positive 300. So this means that if there is a sign of negative inside the modulus, we take always positive value. Let's take a detailed look into quadratic inequalities. An inequality with a quadratic expression in one variable on one side and 0 on the other is called a quadratic inequality in one variable. For example, x minus 1 times x minus 4 is less than 0. So this is a quadratic inequality in x. The range of values of x which satisfy this inequality can be formed from the quadratic curve y equals x minus 1 times x minus 4 as follows. X minus 1 equals 0, from here you got x is equal to 1, and x minus 4 equals 0, from here you get x is equal to 4. So if you multiply both x, you get x square, which is positive. So the curve looks like this. So take a look at the diagram. So below the x-axis, y is negative, and above the x-axis, y is positive. So y is greater than 0 above the x-axis and y is less than 0 below the x-axis. For x minus 1, x minus 4 less than 0, that is y is negative, we choose the interval for which the curve is below the x-axis. Therefore, x minus 1, x minus 4 if less than 0, so we write x is less than 4 greater than 1. Similarly, if x minus 1, x minus 4 is greater than 0, that is y is positive, we choose the interval where the curve is above the x-axis. Therefore, x minus 1, x minus 4 greater than 0, we write the answer x is less than 1 or x is greater than 4. Let's solve the inequality 2x greater than x minus 1 modulus. Using the method mentioned in the syllabus, a modulus equals b modulus, which was same as writing a square equals b square. As I told you, this a square equals b square comes by squaring both sides. Now square both sides. So you get 4 square greater than x square minus 2x plus 1. So 4 square minus x square plus 2x minus 1 is greater than 0. Now use a midterm break. First simplify it. So 4x square minus x square is 3x square plus 2x minus 1 is greater than 0. Now make the factors. So you get 3x square plus 3x minus x minus 1 greater than 0. So 3x x plus 1 minus 1 x plus 1 greater than 0. Make the bracket of 3x minus 1 and choose x minus x plus 1, so greater than 0. So from here you get x is equal to 1 by 3, x is equal to negative 1. As inequality is greater than 0, our answer should be in the format x is less than minus 1 or x is greater than 1 by 3. Look this diagram. I'm shading the blue color. So this side we have to choose. The process of verification is important in the process of squaring both sides. We are likely to get extra root. So let's verify. For x is greater than 1 by 3, take any value greater than 1 by 3. Let's take 2 by 3. Place this value in the main inequality. 2x is greater than x minus 1 modulus. And now simplify this. You get 4 over 3 is greater than 1 by 3. So, and this is true. 4 over 3 is definitely greater than 1 by 3. For x less than negative 1, take any value less than negative 1. Let's take negative 2. Place this value in the main inequality. You get negative 4 is greater than 3. It's not true. So we will consider x is greater than 1 by 3 as our final solution. Now few questions to practice.